Hello everyone, I'm Paul and today we're solving problem 3355, 0 array transformation 1. This is a medium problem and actually there's one easy trick we can use here, so keep watching. We're given an integer array nums and a 2D array queries. And each query has two values, left and right. And for each query we can select a subset of indices within the range left and right and decrement the values at the selected indices by 1. And our goal is to return true if we can transform nums into a zero array, meaning an array with all zeros, or false if we can't. So let's see an example. Let's say this is nums, this is queries, and these are the indices in nums. We can take this query and subtract 1 from every element in nums from index 1 up to index 3. So this would become a 1, this would become a 1, and this would become a 0. Next, we can take this query and subtract 1 from every element from index 0 up to index 2. So this would become 0, this would become 0, and this would become 0. And given that we can build an array with all zeros, we can return true. Now at first you can think about iterating over queries, and each time iterating from left to right indices and subtracting 1 from the corresponding elements in nums, but actually that's not efficient. Every number can be up to 10 to the power 5, and we can have up to 10 to the power 5 queries, so that's a very big time complexity. We need to think about something more efficient, for example something that runs in big O of n. And luckily for us, there's one simple trick that we can use here. We can use what's called a difference array and a prefix sum. So let's see how this works. First, we want to build an array with all zeros of length n plus 1. You will see why in a few minutes. So this has 4 elements and this has a length of 5. And next, we are iterating every one of these queries, and each time we want to add the effect of each one of these queries into this new array. Let's see how. First, we take the left index and we add 1 to the element in that index. So this is now 1. And next we take the right index and we subtract 1 at index right plus 1. So this is 3. This means that at index 0, 1, 2, 3, 4 here we subtract 1. So this is now minus 1. What this means is the following. Remember that we are storing this as effects in this array. If we have a 1 here, this means that every future value will be incremented by 1. So this will be incremented by 1, this will be incremented by 1 up to this point. Here we have another effect which is minus 1. So this will go all the way through these elements up to here. And here we have a minus 1. What this means is this effect ends here. Okay? So the next query is 0, 2. This means we are adding 1 here at the index 0. And we are subtracting 1 at index 2 plus 1. So the element at index 3 is now minus 1. This is step 1, and step 2 is to do a prefix sum on this array. This is how we can translate these effects into specific values for each element. So in case you don't know how to build a prefix sum, each element in the array will contain the total sum up to that element. So now we are here and the total sum is 1. Now we are here and the total sum is 1 plus 1, which is 2. Next, here the total sum is 2 plus 0, which is 2. Next, the sum is 2 plus minus 1, so this is 1. And next, the sum is 1 plus minus 1, so this is 0. And now look what we have here. Here we have the result of these queries one by one. So from 1 to 3 we added a 1. Here we added 1 in each of these elements. And from 0 to 2 we did the same. So here we added 1, here we did the same, and here we did the same. Now we can use this array to find the solution. We can iterate this from left to right, and if every element in this array is bigger or equal to the element in this array, we return true. So for example here, 1 equals 1, so this is okay. 2 equals 2, so this is okay. 2 equals 2, and 1 equals 1. So we return true. Time complexity for this will be big O of n plus q, and space complexity will be big O of n plus 1. So now let's go with the code, and hopefully you will get the idea. First, n equals length of nonce. We are building an array with all zeros. This is times n plus 1. And now we are iterating queries, and each query will give us left and right values. So for left, right in queries, array at left plus equal 1, and array at right plus 1 minus equal 1. Now we want to build our prefix sum, so for I in range from 1 up to n plus 1, array at I plus equal array at I minus 1. And with this array we can get the result. So for I in range n, if at any point nonce at I is greater than array at I, we return false. And if we reach the end of this loop and we never return false, we return true. So this is the entire code, and now let's submit this and see if it works. And as you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.